Cascading Style Sheets is a style sheet language used for describing the look and formatting of a document written in a markup language. While most often used to style web pages and user interfaces written in HTML and XHTML, the language can be applied to any kind of XML document, including plain XML, SVG and XUL. CSS is a cornerstone specification of the web, and almost all web pages use CSS style sheets to describe their presentation. CSS is designed primarily to enable the separation of document content from document presentation, including elements such as the layout, colors, and fonts. This separation can improve content accessibility, provide more flexibility and control in the specification of presentation characteristics, enable multiple pages to share formatting, and reduce complexity and repetition in the structural content. CSS can also allow the same markup page to be presented in different styles for different rendering methods, such as on screen, in print, by voice and on braille-based, tactile devices. It can also be used to allow the web page to display differently depending on the screen size or device on which it is being viewed. While the author of a document typically links that document to a CSS file, readers can use a different style sheet, perhaps one on their own computer, to override the one the author has specified. However, if the author or the reader did not link the document to a specific style sheet, the default style of the browser will be applied. CSS specifies a priority scheme to determine which style rules apply if more than one rule matches against a particular element. In this so-called cascade, priorities or weights are calculated and assigned to rules, so that the results are predictable. The CSS specifications are maintained by the World Wide Web Consortium. Internet Media Type Text CSS is registered for use with CSS by RFC 2318, and they also operate a free CSS validation service. Syntax: CSS is a simple syntax and uses a number of English keywords to specify the names of various style properties. A style sheet consists of a list of rules. Each rule or rule set consists of one or more selectors, and a declaration block. Selector: in CSS, selectors are used to declare which part of the markup a style applies to, a kind of match expression. Selectors may apply to all elements of a specific type, for example the second-level headers H2, to elements specified by attribute, in particular, an identifier unique to the document, class. To elements depending on how they are placed relative to, or nested within, others in the document tree. Classes and IDs are case-sensitive, start with letters, and can include alphanumeric characters and underscores. Any number of instances of any number of elements may have the same class. Conventionally, IDs only apply to one instance of one element. Pseudo-classes are used in CSS selectors to permit formatting based on information that is outside the document tree. An often used example of a pseudo-class is hover, which identifies content only when the user points to the visible element, usually by holding the mouse cursor over it. It is appended to a selector as in a hover or elemented hover. A pseudo-class classifies document elements, such as link or visited, whereas a pseudo-element makes a selection that may consist of partial elements, such as first line or first letter. Selectors may be combined in many ways, especially in CSS 2.1, to achieve great specificity and flexibility. Multiple selectors may be joined in a spaced list to specify elements that fit all the selectors. The order of the selectors is important. For example, div myClassColor, red, applies to all elements of class myClass that are inside div elements, whereas myClassDivColor, red, applies to all div elements that are in elements of class myClass. A simple summary of the selector syntax indicating usage and time of introduction. Declaration block: a declaration block consists of a list of declarations in braces. Each declaration itself consists of a property, a colon, and a value. If there are multiple declarations in a block, a semicolon must be inserted to separate each declaration. Properties are specified in the CSS standard. Each property has a set of possible values. Some properties can affect any type of element, and others apply to particular groups of elements. Values may be keywords, such as center, or inherit, or numerical values, such as 200px or 80%. Color values can be specified with keywords, hexadecimal values, RGB values on a 0 to 255 scale, RGBA values that specify both color and opacity, or HSL or HSLA values, HSLA, 000, 100%, 50%, 80%. Use. Before CSS, nearly all of the presentational attributes of HTML documents were contained within the HTML markup. All font colors, background styles, element alignments, borders and sizes had to be explicitly described, often repeatedly, within the HTML. CSS allows authors to move much of that information to another file, the style sheet, resulting in considerably simpler HTML. Headings, subheadings, subheadings, etc., are defined structurally using HTML. In print and on the screen, choice of font, size, color and emphasis for these elements is presentational. Before CSS, document authors who want to assign such typographic characteristics to, say, all H2 headings had to repeat HTML presentational markup for each occurrence of that heading type. This made documents more complex, larger, and more error-prone and difficult to maintain. CSS allows the separation of presentation from structure. CSS can define color, font, text alignment, size, borders, spacing, layout and many other typographic characteristics, and can do so independently for on-screen and printed views. CSS also defines non-visual styles such as the speed and emphasis with which text is read out by oral text readers. The W3C has now deprecated the use of all presentational HTML markup. For example, under pre-CSS HTML, a header element defined with red text would be written as. Using CSS, the same element can be coded using style properties instead of HTML presentational attributes. An external CSS file, as described below, can be associated with an HTML document using the following syntax. An internal CSS code can be typed in the head section of the code. The coding is started with the style tag. For example, sources, CSS information can be provided from various sources. These sources can be the web browser, the user and the author. The information from the author can be further classified into inline, media type, importance, selector specificity, rule order, inheritance and property definition. CSS style information can be in a separate document or it can be embedded into an HTML document. Multiple style sheets can be imported. Different styles can be applied depending on the output device being used. For example, the screen version can be quite different from the printed version, so that authors can tailor the presentation appropriately for each medium. The style sheet with the highest priority controls the content display. Declarations not set in the highest priority source are passed on to a source of lower priority, such as the user agent style. This process is called cascading. One of the goals of CSS is also to allow users greater control over presentation. Someone who finds red italic headings difficult to read may apply a different style sheet. Depending on the browser and the website, a user may choose from various style sheets provided by the designers, or may remove all added styles and view the site using the browser's default styling, or may override just the red italic heading style without altering other attributes. CSS priority scheme, specificity. Specificity describes the relative weights of various rules. It determines which styles are applied to an element when more than one rule could apply. Based on specification, a simple selector has a specificity of 1, class selectors have a specificity of 1, 0, and ID selectors a specificity of 1, 0, 0. Because the specificity values do not carry over as in the decimal system, commas are used to separate the digits. Thus the following rule selectors result in the indicated specificity. Example of specificity, consider this HTML fragment. In the above example, the color of the P element would be blue. The declaration in the style attribute will override the one in the style element since it has a higher specificity. Inheritance. Inheritance is a key feature in CSS. It relies on the ancestor-descendant relationship to operate. Inheritance is the mechanism by which properties are applied not only to a specified element, but also to its descendants. Inheritance relies on the document tree, which is the hierarchy of HTML elements in a page based on nesting. Descendant elements may inherit CSS property values from any ancestor element enclosing them. In general, descendant elements inherit text-related properties, but box-related properties are not inherited. Properties that can be inherited are color, font, letter spacing, line height, list style, text align, text indent, text transform, visibility, white space and word spacing. Properties that cannot be inherited are background, border, display, float and clear, height and width, margin, min and max height and width, outline, overflow, padding, position, text decoration, vertical align and z-index. Inheritance prevents certain properties from being declared over and over again in a style sheet, allowing the software developers to write less CSS. It enhances faster loading of web pages by users and enables the clients to save money on bandwidth and development costs. Example of inheritance, given the following style sheet. Suppose there is an H1 element with an emphasizing element inside. If no color has been assigned to the M element, the emphasized word illustrate will inherit the color of the parent element, H1. The style sheet H1 has the color pink, hence, the M element will likewise be in pink. Whitespace between properties and selectors is ignored. This code snippet is functionally equivalent to this one. One common way to format CSS for readability is to indent each property and give it its own line. History. The first instance of what later came to be CSS, was in Tim Berners-Lee's Next browser editor. The browser was developed in such a way that the style of document could be separated and defined in a simple style sheet. The first paper discussing the need for a cascading style sheet language was published in August 1995 within a paper titled A Methodology for a Structured Hypermedia Design. Communications. Style sheets have existed in one form or another since the beginnings of standard generalized markup language in the 1980s. Cascading style sheets were developed as a means for creating a consistent approach to providing style information for web documents. As HTML grew, it came to encompass a wider variety of stylistic capabilities to meet the demands of web developers. This evolution gave the designer more control over site appearance, at the cost of more complex HTML. Variations in web browser implementations, such as Viola WWW and World Wide Web, made consistent site appearance difficult, and users had less control over how web content was displayed. Robert Kyle wanted to separate the structure from the presentation. The ideal way would be to give the user different options and transferring 3 different kinds of style sheets, one for printing, one for the presentation on the screen and one for the editor feature. To improve web presentation capabilities, 9 different style sheet languages were proposed to the World Wide Web Consortium's www style mailing list. Of the 9 proposals, 2 were chosen as the foundation for what became CSS, Cascading HTML Style Sheets, and Stream-Based Style Sheet Proposal. CHSS, a language that has some resemblance to today's CSS, was proposed by Ha-Yen Kum-Rim Lai on October 10, 1994. Detailing the need for a style sheet scheme for HTML documents. Bert Boss was working on a browser called Argo, which used its own style sheet language called SSP. Lai and Eve Laffin joined Dave Raggett to expand the Arena browser for supporting CSS as a testbed application for the W3C. Lai and Boss worked together to develop the CSS standard. Unlike existing style languages like DSSSL and FOSI, CSS allowed a document style to be influenced by multiple style sheets. One style sheet could inherit or cascade from another, permitting a mixture of stylistic preferences controlled equally by the site designer and user. Li's proposal was presented at the Mosaic and the Web Conference in Chicago, Illinois in 1994, and again with Bert Boss in 1995. Around this time the W3C was already being established, and took an interest in the development of CSS. It organized a workshop toward that end chaired by Stephen Pemberton. This resulted in W3C adding work on CSS to the deliverables of the HTML Editorial Review Board. Li and Boss were the primary technical staff on this aspect of the project, with additional members, including Thomas Reardon of Microsoft, participating as well. In August 1996 Netscape Communication Corporation presented an alternative stylesheet language called JavaScript Stylesheets. The spec was never finished and is deprecated. By the end of 1996, CSS was ready to become official, and the CSS Level 1 recommendation was published in December. Development of HTML, CSS, and the DOM had all been taking place in one group, the HTML Editorial Review Board. Early in 1997, the ERB was split into three working groups: HTML Working Group, chaired by Dan Connolly of W3C; DOM Working Group, chaired by Lauren Wood of SoftQuad; and CSS Working Group, chaired by Chris Lilly of W3C. The CSS Working Group began tackling issues that had not been addressed with CSS Level 1, resulting in the creation of CSS Level 2 on November 4, 1997. It was published as a W3C recommendation on May 12, 1998. CSS Level 3, which was started in 1998, is still under development as of 2014. In 2005 the CSS working groups decided to enforce the requirements for standards more strictly. This meant that already published standards like CSS A2.1, CSS A3 selectors and CSS A3 text were pulled back from candidate recommendation to working draft level. Difficulty with adoption: the CSS A1 specification was completed in 1996. Microsoft's Internet Explorer 3 was released in that year, featuring some limited support for CSS. But it was more than 3 years before any web browser achieved near full implementation of the specification. Internet Explorer 5.0 for the Macintosh, shipped in March 2000, was the first browser to have full CSS A1 support, surpassing Opera, which had been the leader since its introduction of CSS support 15 months earlier. Other browsers followed soon afterwards, and many of them additionally implemented parts of CSS A2. As of August 2010, no browser had fully implemented CSS A2, with implementation levels varying. Even though early browsers such as Internet Explorer 3 and 4, and Netscape 4X had support for CSS, it was typically incomplete and had many bugs that prevented their implementations from being usefully adopted. When later version 5 feed browsers began to offer a fairly full implementation of CSS, they were still incorrect in certain areas and were fraught with inconsistencies, bugs and other quirks. The proliferation of such CSS-related inconsistencies and even the variation in feature support has made it difficult for designers to achieve a consistent appearance across browsers and platforms. Some authors resorted to workarounds such as CSS hacks and filters. Problems with browsers' patchy adoption of CSS, along with errata in the original specification, led the W3C to revise the CSS A2 standard into CSS A2.1, which moved nearer to a working snapshot of current CSS support in HTML browsers. Some CSS A2 properties that no browser successfully implemented were dropped, and in a few cases, defined behaviors were changed to bring the standard into line with the predominant existing implementations. CSS A2.1 became a candidate recommendation on February 25, 2004, but CSS A2.1 was pulled back to working draft status on June 13, 2005, and only returned to candidate recommendation status on July 19, 2007. In the past, some web servers were configured to serve all documents with the file name extension CSS as MIME type application X.Plus rather than text CSS. At the time, there was a software product on the market to convert PowerPoint files into compact slideshow files using the CSS extension. Variations, CSS has various levels and profiles. Each level of CSS builds upon the last, typically adding new features and typically denoted as CSS-A1, CSS-A2, CSS-A3, and CSS-A4. Profiles are typically a subset of one or more levels of CSS built for a particular device or user interface. Currently there are profiles for mobile devices, printers, and television sets. Profiles should not be confused with media types, which were added in CSS-A2. CSS1, the first CSS specification to become an official W3C recommendation, is CSS Level 1, published in December 17, 1996. Ha-Yen Kun Wim Lai and Baz Boss are credited as the original developers. Among its capabilities are support for font properties such as typeface and emphasis, color of text, backgrounds, and other elements, text attributes such as spacing between words, letters, and lines of text, alignment of text, images, tables and other elements, margin, border, padding, and positioning for most elements, unique identification and generic classification of groups of attributes. The W3C no longer maintains the CSS1 recommendation. CSS2, CSS Level 2 specification was developed by the W3C and published as a recommendation in May 1998. A superset of CSS-A1, CSS-A2 includes a number of new capabilities like absolute, relative, and fixed positioning of elements and Z-index, the concept of media types, support for oral style sheets and bidirectional text, and new font properties such as shadows. The W3C no longer maintains the CSS-A2 recommendation. CSS 2.1, CSS Level 2 Revision 1, often referred to as CSS 2.1, fixes errors in CSS-A2, removes poorly supported or not fully interoperable features and adds already implemented browser extensions to the specification. To comply with the W3C process for standardizing technical specifications, CSS-A 2.1 went back and forth between working draft status and candidate recommendation status for many years. CSS 2.1 first became a candidate recommendation on February 25, 2004, but it was reverted to a working draft on June 13, 2005 for further review. It returned to candidate recommendation on July 19, 2007 and then updated twice in 2009. However, since changes and clarifications were made, it again went back to last call working draft on December 7, 2010. CSS 2.1 went to proposed recommendation on April 12, 2011. After being reviewed by the W3C Advisory Committee, it was finally published as a W3C recommendation on June 7, 2011. CSS 3. Unlike CSS-A2, which is a large single specification defining various features, CSS-A3 is divided into several separate documents called modules. Each module adds new capabilities or extends features defined in CSS-A2, preserving backward compatibility. Work on CSS Level 3 started around the time of publication of the original CSS-A2 recommendation. The earliest CSS-A3 drafts were published in June 1999. Due to the modularization, different modules have different stability and statuses. As of June 2012, there are over 50 CSS modules published from the CSS Working Group, and 4 of these have been published as formal recommendations. June 19, 2012, Media Queries, September 29, 2011, Namespaces, September 29, 2011, Selectors Level 3, June 7, 2011, Color. Some modules have candidate recommendation status and are considered moderately stable. At creek stage, implementations are advised to drop vendor prefixes. Summary of all module specifications, CSS4, there is no single, integrated CSS4 specification, since it is split into separate modules. However, there are Level 4 modules. Since CSS3 split the CSS language's definition into modules, the modules have been allowed to level independently. Most modules are Level 3, they build on things from CSS 2.1. A few Level 4 modules exist, which build on the functionality of a preceding Level 3 module. others define entirely new functionality, such as Fluxbox. So, while no monolithic CSS4 will be worked on after CSS3 is finished completely, the Level 4 modules can collectively be referred to as CSS4. Browser support. Because not all browsers correctly parse CSS code, developed coding techniques known as CSS hacks can either filter specific browsers or target specific browsers. The former can be defined as CSS filtering hacks and the latter can be defined as CSS targeting hacks. Both can be used to hide or show parts of the CSS to different browsers. This is achieved either by exploiting CSS handling quirks or bugs in the browser, or by taking advantage of lack of support for parts of the CSS specifications. Using CSS filters, some designers have gone as far as delivering different CSS to certain browsers to ensure designs render as expected. Because very early web browsers were either completely incapable of handling CSS, or rendered CSS very poorly, designers today often routinely use CSS filters that completely prevent these browsers from accessing any of the CSS. Internet Explorer support for CSS began with IE 3.0 and increased progressively with each version. By 2008, the first beta of Internet Explorer 8 offered support for CSS 2.1 in its best web standards mode. An example of a historically well-known CSS browser bug was the Internet Explorer box model bug, where box widths are interpreted incorrectly in several versions of the browser, resulting in blocks that are too narrow when viewed in Internet Explorer, but correct in standards-compliant browsers. The bug can be avoided in Internet Explorer 6 by using the correct doc type in HTML documents. CSS hacks and CSS filters are used to compensate for bugs such as this, just one of hundreds of CSS bugs that have been documented in various versions of Netscape, Mozilla Firefox, Opera, and Internet Explorer. Even when the availability of CSS-capable browsers made CSS a viable technology, the adoption of CSS was still held back by designers' struggles with browsers' incorrect CSS implementation and patchy CSS support. Even today, these problems continue to make the business of CSS design more complex and costly than it was intended to be, and cross-browser testing remains a necessity. Other reasons for the continuing non-adoption of CSS are its perceived complexity, authors' lack of familiarity with CSS syntax and required techniques, poor support from authoring tools, the risks posed by inconsistency between browsers and the increased costs of testing. Currently there is strong competition between the WebKit layout engine used in Apple Safari and Google Chrome, the similar HTML engine used in KDE's Concurror browser and Mozilla's Gecko layout engine used in Firefox. Each of them is leading in different aspects of CSS. As of August 2009, Internet Explorer 8, Firefox 2 and 3 have reasonably complete levels of implementation of CSS 2.1. Limitations. Some noted limitations of the current capabilities of CSS include, selectors are unable to ascend, CSS currently offers no way to select a parent or ancestor of an element that satisfies certain criteria. CSS Selectors Level 4, which is still in working draft status, proposes such a selector, but only as part of the A-E completer selector profile, not the A-O profile used in dynamic CSS styling. A more advanced selector scheme would enable more sophisticated style sheets. The major reasons for the CSS Working Group previously rejecting proposals for parent selectors are related to browser performance and incremental rendering issues. Vertical control limitations are, while horizontal placement of elements is generally easy to control, vertical placement is frequently unintuitive, convoluted, or outright impossible. Simple tasks, such as centering an element vertically or getting a footer to be placed no higher than bottom of viewport, either require complicated and unintuitive style rules, or simple but widely unsupported rules. Absence of expressions. There is currently no ability to specify property values as simple expressions. This would be useful in a variety of cases, such as calculating the size of columns subject to a constraint on the sum of all columns. However, a working draft with a calc value to address this limitation has been published by the CSSWG. Internet Explorer versions 5 to 7 support a proprietary expression statement, with similar functionality. This proprietary expression statement is no longer supported from Internet Explorer 8 onwards, except in compatibility modes. This decision was taken for standards compliance, browser performance, and security reasons. Lack of column declaration. While possible in current CSS A3, layouts with multiple columns can be complex to implement in CSS A2.1. With CSS A2.1, the process is often done using floating elements, which are often rendered differently by different browsers, different computer screen shapes, and different screen ratios set on standard monitors. Cannot explicitly declare new scope independently of positioner. Scoping rules for properties such as z-index look for the closest parent element with a position, absolute or position, relative attribute. This odd coupling has undesired effects. For example, it is impossible to avoid declaring a new scope when one is forced to adjust an element's position, preventing one from using the desired scope of a parent element. Pseudo-class dynamic behavior not controllable here. CSS implements pseudo-classes that allow a degree of user feedback by conditional application of alternate styles. One CSS pseudo-class, hover, is dynamic and has potential for abuse, but CSS has no ability for a client to disable it or limit its effects. Cannot name rules. There is no way to name a CSS rule, which would allow client-side scripts to refer to the rule even if its selector changes. Cannot include styles from a rule into another rule here. CSS styles often must be duplicated in several rules to achieve a desired effect, causing additional maintenance and requiring more thorough testing. Cannot target specific text without altering markup. Besides the first letter pseudo-element, one cannot target specific ranges of text without needing to utilize placeholder elements. Advantages: separation of content from presentation. CSS facilitates publication of content in multiple presentation formats based on nominal parameters. Nominal parameters include explicit user preferences, different web browsers, the type of device being used to view the content, the geographic location of the user and many other variables. Site-wide consistency. When CSS is used effectively, in terms of inheritance and cascading, a global style sheet can be used to affect and style elements site-wide. If the situation arises that the styling of the elements should need to be changed or adjusted, these changes can be made by editing rules in the global style sheet. Before CSS, this sort of maintenance was more difficult, expensive and time-consuming. Bandwidth. A style sheet, internal or external, specifies the style once for a range of HTML elements selected by class, type or relationship to others. This is much more efficient than repeating style information in line for each occurrence of the element. An external style sheet is usually stored in the browser cache, and can therefore be used on multiple pages without being reloaded, further reducing data transfer over a network. Page reformatting. With a simple change of one line, a different style sheet can be used for the same page. This has advantages for accessibility, as well as providing the ability to tailor a page or site to different target devices. Furthermore, devices not able to understand the styling still display the content. Accessibility. Without CSS, web designers must typically lay out their pages with techniques such as HTML tables that hinder accessibility for vision-impaired users. CSS Frameworks. CSS frameworks are pre-prepared libraries that are meant to allow for easier, more standards-compliant styling of web pages using the Cascading Style Sheets language. CSS frameworks include Blueprint, Bootstrap, Foundation and Cascade Framework. Like programming and scripting language libraries, CSS frameworks are usually incorporated as external CSS sheets referenced in the HTML head. They provide a number of ready-made options for designing and laying out the web page. While many of these frameworks have been published, some authors use them mostly for rapid prototyping, or for learning from, and prefer to handcraft CSS that is appropriate to each published site without the design, maintenance and download overhead of having many unused features in the site styling. Positioning. CSSA 2.1 defines three positioning schemes: normal flow, and line items are laid out in the same way as the letters and words in text, one after the other across the available space until there is no more room, then starting a new line below. Block items stack vertically, like paragraphs and like the items in a bulleted list. Normal flow also includes relative positioning of block or inline items, and run-in boxes. Floats: a floated item is taken out of the normal flow and shifted to the left or right as far as possible in the space available. Other content then flows alongside the floated item. Absolute positioning: an absolutely positioned item has no place in, and no effect on, the normal flow of other items. It occupies its assigned position in its container independently of other items. Position: top, bottom, left, and right. There are four possible values of the position property. If an item is positioned in any way other than static, then the further properties top, bottom, left, and right are used to specify offsets and positions. Static: the default value places the item in the normal flow. Relative: the item is placed in the normal flow, and then shifted or offset from that position. Subsequent flow items are laid out as if the item had not been moved. Absolute specifies absolute positioning. The element is positioned in relation to its nearest non-static ancestor. Fixed: the item is absolutely positioned in a fixed position on the screen even as the rest of the document is scrolled. Float and clear: the float property may have one of three values. Absolutely positioned or fixed items cannot be floated. Other elements normally flow around floated items, unless they are prevented from doing so by their clear property. Left: the item floats to the left of the line that it would have appeared in. Other items may flow around its right side. Right: the item floats to the right of the line that it would have appeared in. Other items may flow around its left side. Clear: forces the element to appear underneath floated elements to the left, right or both sides. See also. References. Further reading. External links. CSS homepage at w3car includes links to the CSS specifications. CSS at DMOZ.